Hello friends, we are today back again with another fungus, another new video and absolutely with another fungus. But this time the fungus is not from the foods or it is not regarded with the foods, but it is regarded with the kitchen and it is regarded with the household. Generally, this fungus is found in the walls, in the dampy region or in some places due to for the construction with dumpy bricks. This fungus is found, and consecutively it comes out, or rather it yeah, protrudes out from the walls. It is elevated from the walls, and it is found in white flakes. And this, if you scrap those flakes and put in a culture media, you will get this fungus. This is maybe stachhybotrys atra, or maybe something else. It can be asparagus also. Maybe it's looking like asparagus. This I will just show you in the moment in the next video. This is the next part of this video, that this is actually looking like asparagus, but it may be Stachybotrys atra. It may be anything like that. So let's see what happens. So we will examine under microscope. But this is found due to the wrong construction of the buildings, and also due to the mm, bad weather, or the bad raining weather, or some dampy winter seasons it passes on. So now which is going on, everybody is catching cold, everybody is catching omicron, so everybody is vulnerable now. So some people are catching omicron, some people are catching cold, but everybody is vulnerable. So this is why this fungus also gets attracted towards the buildings also, and therefore this fungus has arrived. So after around 15 days culture, this wall fungus I have just gone. It is has been in MSA agar, that is mannitol salt agar, so sodium chloride agar. So it has been done, and it is got a very beautiful structure. It's a round cylinder, round circular structure, and you can see. So we will see the morphology, and then we will examine under the microscope.
Fungus from the laparoscopic camera. This is a laparoscopic camera view which is found given inside the flask. We have gone inside the flask and you can clearly see the circumference of the circular nature of this fungus. So this is an inside flask view. As you can see, this is a mold fungus, almost a mold fungus, mold and gray fungus with the two circular molds. So this is a this may be a very complicated fungus, maybe aspergillus, maybe black fungus, or maybe Stachybotrys atra. But that will be under vision after we see through a microscope. But this is a laparoscopic view. So this is these are the other patches, other symmetrical patches you can see. This is the laparoscopic view. So we can see this from inside the flask. This is a very clear picture, as you can see this picture. So this is a laparoscopic view. So this we will see after microscopic view. We will see better under microscopic view. So this is the laparoscopic view, as you can see.
So friends, we are the next part of the video of this wall fungus. After 5 days, we have seen this fungus growth. As you have seen in the previous part of this video, there is the laparoscopic view. I have shown you this circumference presence of the colonies. You have seen the colonies, the macroscopic colonies. Now we have morcellated the fungus, because that much big colony you cannot see under microscope. You cannot estimate the morphology, the microscopical morphology, exact microscopical structure. You cannot determine. So for that we have to morcellate, as you know. So we have morcellated this fungus. So now it has become this much. So you can see in this camera, it is now has become like this. So we will be putting this fungus inside the culture media, and we will be mm, observing after 15 minutes, observing under microscope, that what is the structure, internal structure of this fungus. So let us begin the putting it into the culture media. But here I would just like to tell you that we will be using a very different kind of culture media.
This is called Brian Parker culture media. This is a very selective culture media with having an amino acid. We have added an amino acid of glycine. So this is also another chemical, lithium chloride and sodium pyruvate. So for this is a specialized agar. It is a Brian Parker medium. It is say after the name of two microvalleys. It's the Brian and Parker. So this we will be using this culture media as you see in the beaker. We can see we will be using this culture media to see the growth of this fungus, this wall fungus. So what is it? So let us begin. First we will put the Brian Parker media as usual inside the culture flask so that the fungus gets additive to the culture media, and we will be using the same pipette, and take around 6 ml of the fresh culture media. In the flask. This is pale yellow straw and straw yellow in color. So when the fungus gets accumulated, so that we will see. After 15 minutes, we will see under microscope what is the structure, or rather what is the scenario of this fungus. Now we are going to put this fungus with the help of a micropipette. We will be taking around 3 ml, 3.5 ml of this fungus from this morphology, and you can see a dense color of this fungus, and we are just inoculating it inside the suspension in the culture media. So let us little bit add more, another 3 ml, so that we will see. So the culture media has settled. So let us discard this fungus and this pipette. So this is a, as you can see, this is a very heavy fungus and it has settled. So let us cover the culture media first, because the fungus will disturb this culture media, may disturb this culture media. Now we will cork this. Just a simple cork. So friends, we are back after 15 minutes, and we will be seeing the morphology of this fungus under first preliminary morphology of this fungus under T400 microscope. So let us assume, let us take 3.5 ml to 3 ml, 3 to 3.5 ml of this fungus. This will identify the fungus. Here we will be able to identify the fungus. From this, we will be able to see the morphological structure, and also we will be able to identify the fungus, what fungus it is, that we will be able to identify. Is it a asparagus, or is it a black fungus, or is it any kind of any kind of either mosses or molds, black molds, maybe black molds, stachhybotrys atra, anything it can be, so that we will be identifying. Generally, these three type of funguses are mostly available in the forms in the walls. There is the stachhybotrys atra, the black molds, the asparagus, or many gray molds or some sort of things like maybe that. So that we will be estimating or just seeing this from this fungus in the petri dish, we will be able to see it. So this we will see under the next part of the video, that is the microscopic video. So now, so as you can see, the presence of the gray mold. So this is a clear geometry of a gray mold. So this is the condition of the wall fungus. It is the morphology is getting, the microscopy is getting focused, and you can see the gray mold, the aneurysm of the gray mold. So trillions of microspores, and these microspores are actually consisting of the mycotoxins, as you can see. So this is the main problem of this main problem of this fungus. So this is the main fungus actually. So this is gray mold. This is a simple mold fungus which accumulates on the walls, so protrudes out from the wall, like a relief map. It's a relief fungus. So it comes out, and this is the microscopical structure after morcellation. So this is a simple gray mold But this is dangerous because this consists of millions of microspores, and these millions of microspores are very dangerous, and that also exactly goes inside the lungs and creates problem. So this is very bad fungus. If it is found in the walls, it should be immediately removed, and an antifungal coating should be layered or painted, or rather painted. Antifungal coating should be painted. So this is another morphology of this grey mold. This is a fan-like morphology. So this is the microspores. This is full of microspores. The tiny, very tiny micropores. These are less than 1 micron in diameter. So this is the main morphology of the grey mold, as you can see.
Hello friends, so we are back after around 7 days again with this same fungus, the green mold. So this has considerably developed. So we can see the color has changed from yellow to red. So already it has formed this chemical change, and it has gone a lot. So now we are going to see the video of how much it has progressed, and how what is the main system of this fungus and how it looks like properly. This will be our second investigation of under TCM400 microscope. After that, we will proceed for fluorescence, where we will be also that we will determine whether it is able to go for fluorescence examination or not. That we will going to inspect. So we will be checking this fungus under TCM400 microscope, and this red solution that we will take, and we will check under TCM400 microscope from this flask. This has now become a sticky mold, almost a sticky mold, and it is a full red system. As you can see, the become mold has become sticky. So we are just taking part, and we will just see how much it has formed. So it has formed a lot. As you can see, it is almost macroscopic. It is almost macroscopic, but we will see it under TCM400 microscope. So it is now, it's a very big fungus now. It is a very big fungus now. So we will see it under TCM400 microscope. So let us begin.
So as you can see, this is the grey mold after advanced culture for about 7 days in the Brad Parker agar. So now it has shown its structure, its fimbrious structure. The frimsians are all visible. So this is almost macroscopic. This fungus has become almost macroscopic. So it is very big now. So it is very difficult to manage under microscope. So anyhow, we are showing the structures. We will be seeing the visualization. This is the dark portions are the molds actually. This is the grey mold. This is the fringes of the grey mold. You're seeing the circumferences of the mold. Main mold you cannot see under microscope because that is a very dark structure. So these are the fringes, as you can see. This is the grey mold. This is the protruding structures coming out from the walls. So these are the grey molds. We are showing the other sides. So this is only 50x magnification, because more than 50x we cannot go. So this is a 50x magnification. So this is grey mold. So as you can see, this is grey mold. So this is the shooting structure. This is the coliform structure of this grey mold, and we are trying to see some other portions, but this is quite a heavy structure. So this is absolutely in a heavy structure. So these are the lacerations, the scales of the grey mold. So these are the scales of grey mold. So these are scales of grey mold, so which is very much visible. So brightness is getting adjusted to show you the molds. It's a very heavy fungus. So you can see now the fluorescence image has arrived, and this is the fluorescence structure of the grey mold. So this is inside the grey mold. The fluorescence is better. Obviously the fluorescence is giving us a better view. These are the fringes. You can see the microscopic fringes of the grey mold. So this is obvious that we will see a better view. We are trying to obtain the main geometry of the fungus because this is a very big fungus, so we are just light is getting adjusted to give you more view. So this is inside the grey mold. We have penetrated inside. As usual, the fluorescence microscopy is much more powerful than phase contrast microscopy. So we are just trying to see the grey mold, and we will be able to see the protruding structures out of the main periphery. So as you can see, this is the main structure. So this is the main structure of the grey mold. So this is the protruding structure of the grey mold, and you can see the head. Right side is head. Right side, that is the head. So this leaning in the right like a thread, a cotton ball is the thread. We can increase the magnification. So the magnification is increased to 400x. So you can see now, you can see the structure better. So we are trying to focus properly. The microscope is focused, and you can see the structure. The protruding head is a nice protruding head, just right side of your screen, just leaning right like a dahlia flower. It is almost like a dahlia flower. It is protruding like, but it is very dangerous. These micropores, all the micropores are inside that round structure, the head, round head. So that is the head of the black grey mold. So that is actually this is the base, and that is the head. And the inside middle is the column. So that you can see, this is the structure of the grey mold. So this is very dangerous fungus found in the walls of the dampy houses. So this should be avoided. And this is the main fluorescent structure of the grey mold. So you can see the structure is a very beautiful fungus. The shape of the fungus is very beautiful. The shape of the fungus is very beautiful, very beautiful. This is the base. You can see the base is protruding out, and it is protruding, producing fringes, and the fringes are forming the heads. And these heads consist of mycotoxins inside, which is visible there. The yellow dots, those are the mycotoxins. And what mycotoxins we will be getting from the fluorescence, from the UV spectroscopy. So this is inside the fungus. Again, we are going inside the fungus, and I'm going to the other end. So you can see some more heads, or some more protrusions, the stumps. These are called stumps actually. So stumps are visible. So this is the stumps. Again, we are seeing the stump stems. Rather, the stumps or stems, some stems. So we are going to again see the stumps. So this is 400x magnification. This is the bridge between the two funguses. So you can see more stumps. So heads are not formed yet. These are much younger. That is a matured fungus. We saw it previously. So these are the stumps, main stumps. The fringes are coming out, which will form the heads in advance. In future, it will form the heads. So this is the stumps. This is the strains actually, the fringes, the flimsy fringes. This produces the head. So this is the fungus. This is another side of the fringes. You can see in 400x magnification. The mycotoxin is right in front of you. It is the green color. That is the mycotoxin. There's the presence of mycotoxins inside. Maybe two or three types of mycotoxins are present. Not only not one. There may be two or three more than one mycotoxins are present in this gray mold. So what mycotoxins we will see. So in the later part of this video we will see. So this is the gray mold. It's a very dangerous fungus and be careful about it. So this is the actual image of the gray mold.
So the UV structure, UV spectrum has arrived, and as you can see, this gray mold is having a very simple mycotoxin, trichothecene, the most common mycotoxin of this type of gray molds, or rather, the species of stachhybotrys atra. It is trichothecene. So the waveform shows is trichothecene. Little bit of patulin is also present, but mostly the main mycotoxin is trichothecene. So this is the curve in front of you. This is the UV curve. You can see the most of the absorbance is near the UV region, and this is the main mycotoxin is trichothecene. So absolutely this